Day 14. We are still looking at the quadratic formula. So I gave you guys a couple of problems, starting with something a little bit different. You're going to see here that I actually wrote the equations with putting them equal to y instead of putting them equal to 0. That's not going to change how we do the quadratic formula. You're still plugging in your a, b, and c, still solving for x. The reason I set it equal to y was just for those of you that wanted to do that optional challenge at the top in red, where I said to write your answer as coordinates. So we'll go over those coordinates as well. It's not as complicated as it sounds. It's really simple when we get down to it. So let's look at number 1. Number 1, we have, and I'm just going to read off the quadratic part of the equation. We've got x squared plus 7x minus 12 equals y. So let's see. I'm going to get my colors ready. B is green. That'll work. Okay, what's our number for A? 1. Good. What's our number for B? 7. How about C? Negative 12. Perfect. Okay, so I gave you a little guide with the quadratic formula and no values put in yet. Using this key, what values are we going to be putting into the blanks here? Let's start with the first one. Yeah, we can start here. We've got negative what? 7. Our B is 7. Plus or minus what? 7 again. It's B squared, so B is 7 squared. Plus negative 4 times what? 1 times what? Good, negative 12. Okay, and then all over 2 times what? 1. Perfect. Okay, so I'm going to take these values to the next page, and we are going to solve this out. So I'm going to rewrite it, copy it down. I've got number 1, x equals negative 7 plus or minus the square root, yes, of 7 squared, and that's 49. 7 squared is 49, plus, what is negative 4 times 1 times negative 12? 48. Good. And all of that is being divided by 2. Perfect. Okay, so what else can we simplify here?
Add 49.
Yeah, what's 48 plus 49?
97.
97. So I'm going to rewrite it all. Negative 7 plus or minus the square root of 97 divided by 2. Good. Okay, now this is something that I was telling some of you whenever I came around and was helping. You could absolutely find the square root of 97 next and write out the 2 separate things, but I realized as I've been working out more of these, it's going to be a lot easier if we just don't worry about figuring this number out just yet. We're going to instead go ahead and split into our 2 separate problems at this point. If you wanted to find the square root of 97 first, that is totally okay. You'll probably still get the exact same answer as long as you're keeping track of those numbers accurately. But let's keep the radical 97, the square root of 97 for this example. So what would my 2 equations be when I separate? Negative 7 plus.
Divided by 2.
Good. And what's my other one?
Negative 7 minus square root of 97 divided by 2.
Good. Okay. So here is where we start typing into our calculators. And I forgot to grab one. This one does not work. Let me grab one of these real quick. And can you guys, yeah, no one's got this number. Okay. So we can just type in the top of our fraction. -7 plus second x squared. That gives us the square root. Remember that, guys, the second button and the x squared button. Square root of 97. From here, we're going to hit equals or enter. And now I have the top of my fraction. So I'm going to usually, while I'm writing workout, I like to keep 3 decimal points just so I can stay as accurate as possible. So I'm going to write 2.84, and if we round it up, it would be 9, but if you put 8, that would be okay too. And it's still divided by 2. Okay. So what would I do next? Just divide by 2. So I'm going to keep that number, divide by 2. And I got 1.42. We're going to keep 2 decimal places. So that is our first x value. How would we write that as a coordinate? Oh, before we answer that, yes, Cedra.
Like, is it okay to keep like another decimal point? Like,
yes.
Okay.
So more decimal points is always going to be better because the more you have, the more accurate your answer is. Yes.
Now, like on the decimal point, the 2.849, I just rounded it up to 2.85.
And that would be just fine too.
Okay,
just fine.
I got 1.243.
That's totally okay. So slightly different answer. However, you're going to get the most accurate result the more decimal points you keep.
Okay.
But I'm not going to mark you off for being 1 point different.
Okay,
I'll be able to see that in your work. What'd you say?
I know how to do it the other way that you've been teaching us. I get this way also.
Yeah.
I guess I need to learn how to plug it in the calculator.
Yes. So I can go over that again if you want. I'll let you grab one. It's the same as the little calculators, actually. It's just that second button and the x squared button. That's how we'll be able to find it. So let's run through the second one, and then I'll demonstrate that once you're settled in. So we're going to type in the second problem here. What am I typing in? -7 minus, good, square root of 97. Good. And this time I got -16.849. -16.849 divided by 2. Okay. All right, so again, if anybody doesn't remember how to get that square root sign on your calculator, I'm going to show everyone again. You just hit second, that blue button at the top left, and then right across from the number 7, you're going to see x squared with a little square root right above it in blue. When you click that, it'll give you your square root.
Okay.
Perfect. Okay, so what do I have left to do here? Divide by 2. So I'm just going to divide by 2. And I get -8.42. -8.42. All right.
That's actually less work.
It is. You see how it didn't take up like a whole page and a half this time? Yes. And you know, the more and more that we do these problems, the more tricks we learn. It starts to come together.
We have to do 3 decimals.
You don't have to. I'm just going to suggest it. I'm not going to count your answer wrong if you don't, but I, as a rule of thumb, use 3 decimals when I'm still putting my work in. So how would I write these as coordinates? This was just an optional challenge. You didn't have to do this part. Does anybody know how to put these in as coordinates? Yeah, Michael.
It would be x would be 1.42 and y would be 0.
Yes. Easy as that. Our x value is 1.42. And remember, the x value that we find looks like this, and it's going to be somewhere on the x-axis. If we have a point on the x-axis, the y value is 0. We're not up or down anywhere. The y value is 0. So as a coordinate, that's what it would be. Yes, Erica.
So are both of our answers for x?
That's why you got an extra point.
Yes, they're both for x. We're going to have two x values.
Coordinate, what is it?
Okay, so let me find my blue so I can label my y.
That extra point, what is it?
Not the right blue, but that's okay. And how would I write the second x value we found as a coordinate?
Negative 8.42 for x,
Yeah,
0 for y.
perfect. It's always going to be 0.
Very smart.
Yes. And that's our x and our y. Good job, guys. Very good job. Before we try doing number 2, does anyone have questions about any part of this? Does anyone, maybe they got a different answer and don't understand how and want to go through any of this? I'm happy to answer questions, you guys. Okay, if not, we'll go ahead on to number 2. All right. So is anybody still looking at this work or can I move it? Okay, let's look at number 2. I have 4x squared minus 5x minus 2. What are my A, B, and C?
4, -5, -2.
Yes, my A is 4, my B is -5, my C is -2. Perfect. So let's plug these values into our quadratic formula.
-5.
Good. -5,
-5.
-5, and then what? My A is 4, -2. And what's my last one?
4.
4. 2A. My A is 4. Good. All right, so there's my values. -5 plus or minus -5 squared plus -4 times -2. All divided by 2 times 4. So I'm going to move that a little bit to the side, and we are going to start simplifying. Okay, so I'm going to write number 2.
X equals 5.
Yes, okay, so we've got x equals our 2 negatives here. They cancel out. This makes a positive 5. 5 plus or minus. Yeah, the square root. -5 squared, that's positive 25. Good. Plus, what's -4 times 4 times -2?
32.
32. And all of that is divided by what? 8. Good job. Very nice. Okay. What could we, yes, I hear you. We're going to simplify that.
25 and 32 together.
Yes, 25 plus 32 is
57.
57. So now we have 5 plus or minus the square root of 57 divided by 8. And what can we do from here?
Break it to your 2 equations.
Yeah, let's break it to our 2 equations. We've got the plus and the minus. So below here, I'm going to write 5 plus the square root of 57 divided by 8. And I'm going to write 5 minus the square root of 57 divided by 8. Okay. What is, let's find this, 5 plus the square root of 57?
12.549.
Yeah, 12.54.
No.
So 12.55.
Yeah, it actually, that's going to round up to 12.55 because I'm not going to ask you to get all that technical. We're not going to do like a professional rounding class today, but I'm fine with 12.55 or 12.49. It's all right if it's off by a little bit. So 12.55 I'm just going to write 5498. And that still needs to be divided by 8. And so let's do that. Divide by 8. And that should give us 1.57. Good. All right. Any questions about this part before we solve the minus equation? So now we've got 5 minus square root of 57. And that's going to give us negative 2.5498. Put that down. Negative 2.598. And it still needs to be divided by 8. Yeah, let's divide by 8. And we get, here,
Oh, I'm done. Sorry.
negative 0.32.
What I got.
Perfect. Perfect. Negative 0.32. Okay. Did you get something different, Elisa? Any questions about this, you guys? Did you have a question?
Oh, where we did the 57 part at, mine's come out to 7 point.
5.4.
Yeah.
Yeah, it is.
Okay, did you add it to 5? So here's what we did. You still did it correctly. What we did is we didn't figure out the square root of 57. We just kept it in our equation. So you said you got 7.54? Okay, so 7.549. If you do 5 plus 7.549, you'll still get 12.549. You'll get the right answer. We just took out one little step, and instead of solving the square root and then plugging it in, I figured out as I was doing a bunch of these that we actually don't need to do that. It just makes it a whole nother step for us. If you do it, you'll still get the right answer.
Oh, but you still simplify.
Yes.
Still simplify. Okay. I
Yes. Okay. Yes.
So for that part, I got 0.386.
What one?
This is like where I did the
The bottom answer?
First one plus 5.7.549.
oh yeah, it's the second part,
Okay.
I think.
Oh.
So what number did you get where?
So I did like the 2.549 divided by 8, and I got the like.
Did you negative? No.
So you got the same answer as us. You said you got 0.318.
Yeah.
We just rounded up to 0.32. Same answer. You got it. It's okay. No, that's perfect. Perfect.
If we do that on the test, you ain't gonna count it wrong, right?
No. I won't count it wrong. I won't. You guys got it. Okay. What would I do to write these as coordinates?
You go back.
7x. And 0 for our y. That's it. You just put a 0 for y. That's it. Because we just found an x value. There's our y. How about the next coordinate?
Go ahead.
I heard it.
0.32.
Yes.
And 0 for y.
Yes.
Thank you.
Perfect, you guys. Perfect. Okay. Any questions about number 2 before we do 3?
No.
Okay. Let's check out number 3. Okay. I'll scooch it up. Okay, so on number 3, I'm gonna just fold this in half. Number 3, we have 3x squared. I forgot to write a, b, and c. Sorry, guys. Plus x minus 6. What's my a, my b, and my c?
3, 1, -6.
Good. So 3 is my a. 1 is my b. -6 is my c. So let's start plugging into the formula. What goes first?
X equals
X equals
negative
-b. What's our b? Yeah, 1. Good. Plus or minus 1 squared plus -4 times 3. Good. Times -6. All over 2 times?
4.
What's our a? Woo, 3.
Oh, I'm on 3. I'm on the wrong.
That's okay. You're all right. Okay, so we got our values plugged in. Let's start simplifying our work. I'm going to do the same thing we did a minute ago. Sorry, guys. I'm like moving around like crazy.
So X equals negative.
Yeah, so let me write number 3. X equals, good, -1 plus or minus square root. It's 1 squared. It's just 1. Plus -4 times 3 times -6. Let's see.
I got 72.
Times 3 times 6. I also got 72. 1 plus 72 divided by what? What's 2 times 3? 6. Okay, and we know 72 plus 1 is 73. -1 plus or minus the square root of 73, all divided by 6. Okay, and I'll wait a second. I know some of us didn't get to number 3 yet, so I'm going to let you guys copy that down if not.
I skipped one.
For my final answer, I got 1.25.
Oh, yeah, I should get one 70.
I haven't worked it out yet, so I don't know what the final answer is, but we'll be able to see it in just a minute. Yes.
How did? Oh, never mind.
You got it?
I got it.
Awesome.
Me too. That's why I'm like, where's the other my paper? Because I did it in my head.
Guess what I was getting?
Bless you.
Yeah.
All right, guys, is everybody caught up to this point, or does anyone need more time? Good? Okay.
We're there.
All right. So, what do we do from here?
Simplify again.
What are we going to simplify?
Well, actually, no, you could break it down to your
We
equation.
could break it down. We could.
-1 plus square root of 73 divided by 6.
Uh-huh.
-1 minus the square root of 73 divided by 6.
-1 plus and -1 minus.
That's a lot to think about.
Yeah, it is. It is a lot to think about.
But when you get it, you got it.
That's right. Okay, so let's figure out the top one. -1 plus the square root of 73. I got 7.544 divided by 6. Okay. And is that what the bottom one is? Oh, you worked it out already. Okay. So 7.544 divided by 6 is 1.26. Perfect.
Well, I ain't got time to
It's all right.
When I was doing that yesterday, I thought you said we couldn't do that.
Do what?
Like if we don't round, we have to round up.
It's gonna depend on what I ask for. Like if I tell you I need you to round to the second one.
At first, but then when you said it and you said the answer could be wrong or something.
Yes. So it depends on the directions I give. Like in this do now, I didn't tell you necessarily how many to round to, but we'll start getting more consistent with our rounding and I'll tell you when I want to make sure you're being accurate on that. But it is a good practice to, if you are trying to put 2 decimal points and you have 1.257, we eventually need to know that that's going to be 1.26. Right now, I'm more focused on making sure we understand this formula. Okay, so we've got the first one. Let's do the second one. -1 minus square root of 73. I got -9.544. You guys also get that? Awesome. Awesome. We'll divide that by 6.
-1.59.
Yeah, -1.59. Perfect. No, I'm never upset about y'all cheering each other on. I love that. Thank you, guys. Good job. Very good job. Okay, so how can we write these as coordinates?
Oh, x equals 1.26, y is 0.
Yes. And how about this one?
X equals -1.59 and y is 0.
Yes. Perfect. 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 And I'm going to label them just because it helps me. My x and y. Very nice, you guys. Is this starting to feel a little better?
It is better.
Good. Yay. That was my goal. Oh, that makes me so happy. That makes me happy. Okay, you guys. Here's what we're going to start talking about next. I gave you a little sneak preview yesterday of graphing. The sneak preview I gave you was a little scarier than what we're actually going to be doing. I showed you how we graph the points, but now we're going to have the points given to us, and we're just going to talk about what they all mean. So I have a worksheet that I'm going to have you all get. Let me put it up here for everybody. And we're going to walk through these together. So don't start filling it out until I explain, because I don't want you to mark it up if, bless you, if we don't need to. All right, so it's just one page. I'm going to have you take one, pass it down, and any extras, bring up to page 1, pass it down. Okay.
Okay.
Okay, that extra fuel. The food and hour.
Minus plus would be 1.26.
She already got this.
Oh, you're doing, oh, this is the, that would be that, like the actions of secondary. Okay, you do these two numbers plus.
I didn't know I would. But I do want. But I know. Shame on you. We'll get you there, don't worry.
Okay. Does everybody have a worksheet? Okay, and then we got extras. No deal. All right, guys. Let's look at the front page. Number 1. This is going to be a lot simpler than yesterday. So, first things first, we have a parabola. That's what this is called, a parabola. This is the graph of a quadratic equation. So the first thing it's going to ask us is, what direction is the parabola opening? This is going to be a simple answer. You write up or down. Is it pointing up or down? Up. So we're going to write up. Perfect. So now this is a little bit different than how we've been naming this. The second thing says number of zeros. So whenever this asks for the number of zeros, it's really asking you for the x values. It's saying when y is 0. So the number of zeros, how many times are we touching the x-axis? First, let's label our x and y axis. I see it's labeled, but I'm going to make it a little more obvious. So I'm going to do X and Y. So how many times does the parabola touch the x-axis? 2 times, one here and one here. So I'm going to write 2. There's 2 of them. Now I want to know the location of the zeros, which are where it touches the x-axis. Yeah, so I see my first one. It's really tiny, but it's touching -2 and +6. So I'm going to write them as a coordinate.
Okay.
-2, 0, and 6, 0. Good. And if it helps, whenever you're looking back at this later, I would highly recommend labeling the graph as well. I'm going to label this as -2, 0, so that we don't just look at these numbers and think, where did this come from? Let's label. And this other one right here is 6, 0. Okay. So now that we've got these labeled, the next column or the next row says the y-intercept. Does anyone remember what a y-intercept is? Michael?
Your line intercepts the y-axis.
Yeah, it's just where is our parabola touching the y-axis? Where is it touching?
-3.
-3, right there. So go ahead. Let's see. Y. Ooh, so this time we won't put the. No, you're right. 0, -3. I was thinking in backwards terms. Yes. So our x is 0. We're not going to the left or the right. We're just moving in the y direction, downward, 3. So we would write 0, -3. And I'm going to label that as well. 0, -3. And if it helps, really, write little x's and y's above all your coordinates. It's not silly. I do it. You can think it's silly if you want, but it helps me. You know, it helps. And colors really help too, I think. Okay. Now, we've got the next row asks us for the, bless you, the axis of symmetry. We talked about that very briefly yesterday. Yes, Erica?
It's gonna be at 2, -4.
Ooh, so I heard 2 different things. Erica, you said it 2 and what?
-4.
The x is at 2, the y is at -4.
Ooh, okay. So 2 right here, and it goes down to -1, 2, 3, 4. So what you actually just found is the vertex. It falls on the axis of symmetry. The axis of symmetry is actually just the invisible line that is in the middle of our graph, like this. See that? And it would be 2. And where is it crossing to? On the x-axis or the y-axis? The x-axis. So we would say x equals 2. Okay. And guys, this is a great paper to keep track of. Remember, you can use all these on quizzes and stuff. So if you've got this, you'll be able to answer these questions again. Okay. So Erica, since you just pointed out the vertex, let's go ahead and label that too. The vertex was at x is 2, y is -4. So the vertex is 2, -4. Okay, so I'm going to also point to that. to -4. Is this a little easier than finding it from all the equations?
Yes, ma'am.
I think so. And it might still feel a little bit uncomfortable just because we've never done this before, okay? I'm not expecting you to be pros yet. Right now, I'm just really introducing it to you. Okay. Yes.
I don't know if I spaced out, but like, why did we skip that one?
The max and min value.
She answered it.
So yeah, the only reason we skipped that is because Erica pointed out our vertex when we were talking about the axis of symmetry. So since we already said it, I went ahead and put it on our answer. We're going to go back to the max and min next. Sorry, I didn't mean to confuse anybody. Okay, so let's talk about what max/min value means. Before I tell you, what do you guys think this might be asking us?
The minimum.
The maximum and the minimum, absolutely.
It could be talking about X or Y if we're talking about Y, then both answers are going to be infinite.
Yeah.
If it's X, then our min is going to be -4.
So correct, but switch your X and Y around and then it's perfectly correct. So let's talk about the X-axis first. Let's talk about the X-axis. Something that we haven't talked about is what a parabola is and how it moves on. So I want you guys to draw little arrows at the end of your parabola like this. Can anybody tell me, what does it mean whenever you have arrows at the ends of something? It goes on forever. It goes on forever to infinity. So whenever we look left to right in the X direction, these arrows are going to continue to get further and further apart for infinity. They will never end. So in the X direction, we would say that our minimum value is negative infinity. Okay, and I'm going to show you how we do that. I'm going to make a parentheses, negative infinity, comma. So this is where negative infinity is. It's as far to the left as you can go. And then we're going to go to infinity or positive infinity. That's to the right. So infinity. That's how we write that.
Oh, what's that?
That's okay. Yes.
So max and min just defines where a parabola ends, yes.
Yeah. So this might be familiar to my Algebra 1 people, and we're not worrying about this today. It's okay if you don't even label this part yet. But what we just found here is our domain. You guys remember that word, domain? Yes. Yes, yes. So, and thank you for asking. I bet you're not the only one that's a little confused. Whenever we have a line, or in this case, a parabola with arrows on the ends, this means that this is going to extend forever and ever and ever for infinity. It's going to never end, keep going in the negative direction. And on this side, it's going to keep going in the positive direction. Whenever they're asking for the maximum or the minimum value and there's no end, there really isn't a maximum or a minimum value. Because there's not a smallest value, we just say that the smallest value is negative infinity, which means it goes in the negative numbers forever and there's never an end. There's never a minimum value. So we use negative infinity to represent that. And same thing with the positive infinity. There's never going to be a maximum value. It's going to go on forever and ever and ever, never end. When that's the case, we say positive infinity.
So those two are not like an X and a Y right there?
Not in this case, no. Not in this case, no. So the max and minimum value, I'm not as worried about right now. This is kind of just like a little bonus. We'll talk more about this later. So don't worry. Don't be stressed if this is confusing you a little. Yes, Erica.
It looks like the max and min for all of these are infinite.
Yeah, they are going to all be infinite. So that's why we're not as worried about this right now, the max and min, because parabolas are always going to be infinite unless there's an endpoint that tells you otherwise. So it's all infinity for now. Okay, so ignoring the max and min for a bit, let's do number 2 together. And then I'm going to see how we do on the rest by ourselves. So for number 2, what direction are we opening? Up. How many zeros or how many places am I touching the x-axis? 2. Where are my zeros?
-9.
Uh-huh.
-3.
So -9, 0. And -3, 0. And Elisa, do you have this worksheet?
Yeah.
Okay, perfect. I didn't remember if you were in here or not. Okay, so we found our zeros. You can label them if it helps. I'm going to label mine. -9, 0. -3, 0. Okay, where are we crossing the y-axis? What's our y-intercept?
Non-zero.
Yeah.
Ooh, okay, so let's think about it. The x value comes first, and then the y value comes second. So let's see, where are we on the y-axis? 9, so we put that in the y slot, right? If we go up to 9 on the y-axis, we put 9 in the y spot, and our x is going to be 0 because we're not going to the left or the right. We're on the y-axis. So 0. So our y-intercept is 0, 9. Where's our axis of symmetry?
-6.
There you go.
Yeah, -6. And it's touching the x-axis. So we've got x equals -6.
Next one, negative.
Next one, you don't have to fill it in, but it's the same as before. Negative infinity, positive infinity. Where's the vertex?
-6 and 3.
Okay, good. -6 and not 3. -3. Good, good. -6, -3. Okay. -6, -3. All right. All right, all right, all right. That's pretty good, guys. So before we kind of move forward, this is optional for you. You know I like to use colors. I'm going to kind of color code some of these just to help us keep track of what point means what. So you're welcome to copy along and do the same thing as me, or you can start working on the rest. But I think I'm going to make my zeros pink. So I'm just doing that to show that that's where those came from. I'm going to make my y-intercept blue. This just kind of helps me visualize personally. Sometimes when I look at a paper that's just a lot of black and white writing, I get lost in it. Yes.
So this is the kind of math that's at the base of art programs like Inkscape that you define what you're doing with the various surfaces.
Pretty much. Yeah, absolutely. Absolutely. You are correct. Okay, I'm going to make the vertex purple. Sure, you won't make it green. Okay. So my thought process in putting color on this is like, if I was going to take a test later on and something like this would be on it, this would help me realize, okay, that's what that is. Okay, that's what that is. You know, I think colors are so helpful. I put lots of them on each of your tables. Please take advantage of them. Obviously, if you don't like colors, you don't have to, but I'm always going to suggest it. All right, guys, I'm going to pause the recording there.